Hello YouTube. Okay, in today's session we will do a demonstration on how we can create some source OLTP systems which we will be using for data modeling, ETL and lakehouse afterwards and data warehousing, all that stuff. So this one is very useful and I really didn't find anything. I mean, I didn't look for hours, but I did do a search on YouTube to find something where we have multiple sources that we can use to create at least few dimension and fact tables, perform some sort of ETL and use that data. So I had to create my own. So if we look at the Docker Compose file, it's pretty simple, pretty easy. We've got PostgreSQL container, this one, which is our main container, that's going to hold the data. And what next we have is the init PostgreSQL. So what it does is basically this one starts after the main PostgreSQL container has started, and it will just create the database structure in there. Once database structure is created, we have got this container called synthetic data. This will basically generate data for us. Now the data, I've created a Docker image for that, which obviously you can see, and you can go and get it if you like to see. You can get it from the Docker Hub and see what's in there. But basically it's just a Python script which checks what's in there already and just starts creating data with the Faker library. We will discuss that more in about it in later part of the video. But for now, it's just that we've got three containers. One is the base database container that's here to stay, and has to be persistent volume because we don't want our data to be if the container restarts, we don't want data to be deleted or removed. So once the base container starts, then the init container kicks in. It installs, it basically creates the database structure in there and the tables and the databases. We've got three databases, which we will go through in a minute. And then this one just fills in the data. In the scripts here, so we've got Python. I just put it there just so we have it if someone wants to see what exactly is happening under the hood. But in here it's not in use. It's actually the script that is in this image, which is downloaded from Docker Hub. So I just put in there just for if anyone wants to see what's happening, or maybe they want to change something or want to run it manually from here instead. We'll go through all of that in a minute. This is the main script that is creating the databases. So we've got three databases: retail, logistics, and accounts databases. So we've got create three databases. Basically, every database have one fact table or transactional table at this point in time because it's OLTP at the moment. And the rest is dimensions. The rest is just the data that supports it, like customers data, like warehouse data, cities data, payment methods data, this kind of stuff. So let's run it, and then we will do a little bit deeper analysis of what exactly happens. So when we run it, Docker Compose up -d build, that should bring up our environment. And if we have a look here, synthetic data is created. It's not going to kick in till obviously the init has created the database. So we wait. Database was created. Now review logs. This will start and inserting some data into the database. I think a better place to have a look at it is the so let's reconnect and open orders table. So as you can see, the data has started coming in. For so far, it's 13,000 records. Okay, now next step, I've added that a README file in there, so it will help whoever wants to configure it. But while we are at it, Let's just quickly have a look at the settings table. Now this is in the retail database, and it's very important because it controls the behavior of how data is inserted. And because we are performing ETL afterwards, that is going to be how our batches are going to run when we run our ETL. So that's important. Plus, if what kind of resources I'm running it, all this on a VM with I think 4 or 8 vCPU. I think 4 would be enough with 8 gig of RAM. Um, and I think 4 gig would suffice as well, but just on the safe side, 8 gig is nothing. So what this settings table has, it has the batch size. Now remember, batch size is the batch size, it's not the initial data that's put in. So what happens is that once the script kicks in, this is that insert, one second please, let me open that script. So once this script kicks in, it would have basically decide what's the batch size, and before the batch size we have to create some so to say dimensional data, the base data, like which customers or which cities and all that information. So that is going to be created by default, and this first load value controls that. So if you have run it and then stopped synthetic data because for whatever reason you decided that you don't want to add more data, or obviously you cannot create all your ETL and all your models and everything in one go. So what you would do is you create with this Docker Compose. Afterwards, once the base data is entered, all you do is you set it to 0. Now what it would do is once you restart the container, it would check this. If this is set to 0 or any non-1 value, it will not insert that basic customer information. It will just basically insert the transactional data, something like in this orders table. So it will just create that. It already has the customer ID, so it's not going to go in there. And this customer ID is used in other databases as well. So everything stays sort of connected. We will go through that in a minute. So going back to the settings table. So once you set it to 0, you save it, and that's it. Next time, if I'm gonna go and I'm gonna start and let's go to container. So if I'm gonna say, all right, I've got enough, or my resource, I don't have enough resources at the moment, or no need for it, I can stop it. Now, if I go back to dbeaver now and have a look, if this is set to 0, next time I start it, it's not going to try and enter customers data. It's not going to try and enter warehouse data or the cities data or the payments methods data. All it's going to do is just create the transactions. And let me quickly show you other databases as well. So for example, logistics. So we've got cities data, for example, here. So we've got 10 cities, but this is our main transactional table. Right, so this is what data batches we are interested in. At the moment, I mean, how we deal with the slowly changing dimensions and how we deal with updates, I think it's too much at this point in time to go into. So what we are doing, what we will go through first in our first iteration of how we perform ETL and data modeling for data warehouse, we would just take insert data, we would run it through ETL, and we would insert it into a data warehouse, and then we will try and create some OLAP cubes on that. So I think that would be the first go. Okay, getting back to the settings table. So yeah, that controls that. This is your batch size. How many rows would you like to be inserted? So that, remember, all 3 databases have their own fact tables or transactional tables that they would have, so 100,000 each. Obviously, if you stop it, it will start somewhere in there. Between those cycles, how many seconds do you want to pause? I've got 60, let's say change it to 600 for me to have run it every 5 minutes, and we will change that because when we running streams, for example, or Spark streaming, we have to run micro batches. So for that, we can just set it to like 10 seconds or something like that. And even with Kafka, when we will go look at Kafka, and we will set obviously how many rows has to be inserted in every batch or micro batch. So we would do that. Okay, continuous load. So as long as this is set to 1, it would keep loading the data. The cycle is going to keep running. As soon as you put it to 0, the cycle will stop. I don't want it to stop, and it really doesn't serve much. Really, it's not very important unless you really want to just keep your Docker container running. The easier option would be just go back to your VS Code, and just as you can see, it's stopped. And if we go back to dbeaver, we can see that the batch is set to 0. And when that's set to 0, here, let's for now change it to 1, save that to 0, and save everything. So in this case, now we're going to run every 5 minutes, which is too much for this video. Let's keep it 60 and save it like that. So we can control. I mean, we can run kind of streaming data with micro batches with Spark streaming, which we will look into later. Once we go through the DWH, we will look into data lakehouses and how a bit of AI, generative AI, and how that fits into the entire data landscape. And because we are talking about everything on-prem, so it makes things a bit difficult because we have limited sets of tools what we can use. So that's that. Let's quickly, so that's the dbeaver, and let's quickly run the batches again. We go back and we simply start it. So once this is started, go back to dbeaver, and this time let's connect to we didn't connect to accounts database, so this is our transactions database, table. And so if you go by transaction ID, as you can see, customer ID, order ID, and this is going to be, so what I'm trying to do is, or what the plan is, we can create like 3 using the bus architecture for data modeling. We can create 3 fact tables with 3 or 4 or 5, maybe 6 dimension tables that would be used for all the fact tables when we run OLAP against it. But for now, if you look at it, 103,000 transactions, and there should be a pause. Let's see, or maybe, yeah, it's still running. So as you can see, you can just stop and start the synthetic data container. I will just keep on inserting the data. And when you change the batch size, that's where you can really create it into a streaming platform. And to be honest, I was looking online to see if I can find something simple like this, where I take a Docker Compose file and just create an environment where we can go through from 0 till all the way till a complete data warehouse. Limited though, but still a complete data warehouse where we can run ETLs, where we can run batch processing, streaming processing, Kafka, Spark, all that stuff. Trino is one thing on my mind, but anyway, for this run I think we would use Airflow and DBT, but we would go to that in the next video. I think in the next demo we will go and install the source database, which we will keep PostgreSQL. I would prefer Oracle, but because of licensing issues, I think we would stick with PostgreSQL. At later point, I wanted to explain sharding, so at later point we would add ClickHouse, and there we would introduce sharding and OLAP over there. But for now, the dimensional models we will keep in a PostgreSQL source destination database. That's going to be DWH and Airflow, and I think with DBT to keep it as SQL as possible. Not to so we avoid Python as much as we can, even though I think that's absolutely necessary, at least some sort of Python. But we'll try and keep it as SQL as possible. So all the DBAs, I mean, my background is a DBA background, and I was very scared, really not comfortable with programming. But when I switched, it was really very, very easy, especially if you're using data frames and pandas and stuff. It's very easy. So I think that's that. Just a quick, if someone wants to see, there's a, I would add the repo address in the description, and at the same time, with so you can just literally use this Docker Compose, and you have your source environment ready without having to do anything else. And then ETL, we will take it from here, from there. So what the plan, I think, would be to go through the next demo of Airflow and the destination database, and after that we should come back to the data model, because we need to know, so we have our sources, we need to know our requirements, and then we basically design our dimensional model, data warehouse dimensional model. And then the ETL is how we take that raw data in our staging or source databases, or whatever sources there are, from that to that dimensional model, how we change it, how, what kind of transformations we do. And that really is it to ETL. And I've seen that people don't pay much attention to data modeling, and they focus a lot more on ETL. ETL is very important, but not as important as that, because when your queries are running, that's your dimensional model, that's handling it, and that's very important. So I guess that's it for today. Thank you very much, and I'll see you in the next video.